So good morning and welcome back again. We are going to finish 8.8. Second part, we say 8.8 is two parts. First part was about infinity's improper integral. Okay. Here we have vertical asymptote integral. And the vertical asymptote integral means that, for example, I have example 1 to 2 x minus 1 dx. In that case, if you have definite integral means that you have integral with boundaries, lower limit and upper limits. So in that case, before you solve anything, think about if I put that one, I'll get 0 in the denominator or not. If I put that one, I'll get 0 or not. Maybe that example changed to like that. So here we have in the problem here in the lower boundary. Here we have the problem is where it's upper boundary, right? How about that one? You can see the problem is where none of them, but I know one is here. So if I put one, yeah, a problem. So we are going to solve that one as we will change the third case. Yeah, we separate them as an infinite case. Yeah. So from 1, not 0, to 1. So x minus 1 dx and plus 1 to 2 dx x minus 1. Why? Because here's the problem, here's the problem. So if the case, we have a lower case, we will solve it so easy. If it's upper also is easy. If it's in the middle or inside the intervals that we have in the boundaries, so we are going to separate the integral to those numbers that give us vertical asymptote. Understood? Yeah, it was like that. Yeah, exactly. You mean in the area? Yeah, so that was about the area to get the zeros, because we have upper x-axis and lower x-axis that way. But here, no, something else. Here we get as a vertical asymptote. That's it. Clear? Good. Now we are going to solve the examples together. So we have from, for example, from 0, positive 0 to 1 square root of x. So I have square root of x from 0 to 1. You can see if I put 0, there will be what? Trouble. We have a problem here. So we will get vertical asymptote. That's why I'm going to change what? To the limit. A approach to 0 from right side, okay? From A to 1, the same game. Just repeat it. Instead of infinity, we change to the numbers. And we have dx square root of x. And you know, I told you if you have a fraction, and because there's a exponent is not 1, I'm going to think about what? No. It's 1 len. If it's not 1 box, d box, right? Bring it to up. So we will get what? A approach to 0 to the from x to power minus 1 over 2 dx. You know why? And then the result will be forget about the limit, just try to solve the integral, and you know that one will be x 1 over 2 over 1 over 2 from a to 1. Am I right? The result of the integral is plus 1 over 1 because we have box d box. Okay, then again forget about the limit. The limit is not our problem because we will make it later. So I'll get down to 2 square root of x from 1 from a to 1. Am I right? Now I'm going to substitute the boundaries. So I have 2 upper minus 2 lower. Understood? Understood? Good. Now then, I'm going to substitute the value. I know that one will be 2 minus 2a. Am I right? And then we are going to separate the limit. So I'll get what? 2 minus 2 limit of a approach to 0, square root of a. And I know if I substitute that one directly, there is no problem. So I'll get 0, right? Square root of 0, 0. That's why I say is equal to 2 minus 0, and I'll get 2. That's the answer. So converge or diverge? What was converge? What was diverge? Converge. So if you get the result, converge. Otherwise, diverge. So we get something, and here we are. Here's the solution. So you can see in the type 2, second type, if maybe we have a asymptote here, maybe we have a asymptote here. Okay. Maybe asymptote is what? Vertical asymptote is here. So here we are. Here we deal with it. Now I'm going to solve that example from 0 to 1. Okay. 1 minus x from 0 to 1. 1 minus x. So example number 4 in your page 498. Understood? So in the Thomas 14. So how we solve that one? Yeah. First of all, where's the vertical asymptote? 1. So I'm going to change. I say is equal to limit a or b or c, whatever you like. So just word, just letter. So I'm going to make a to 1. Okay. Now tell me, I have from 0 to 1. So my limit is going to here. That one is positive part or negative part? Huh? No, you are wrong. Positive is here. You say positive because I wrote positive. No, not about sign. I talk about, no, about 1. When you say limit, wait, it's okay, do not mix. When we have limits, we have limit. Here, we approach to the number from both sides. Here is the limit from positive. Why positive? When you say positive, means that we are talking about 1 and more, a bit more, right? So a bit more means that positive. When I'm coming to here, means that I am close to 1 from the left side, means that a little bit less than 1. So less than 1 is like that. It might mean 0.9999. That one mean 0.999. That one mean 1.0001, right? And go on. So means that I'm dealing about a number like that. And don't worry, when you have from 0 to 1, and 1 is the vertical asymptote, be sure that you are here. Your boundary is here, right? So we are talking to here. So here's what? Negative. So how about if I change that example from 1 to 2 dx x minus 1, for example. My problem is here, right? So I am from 1 to 2, my boundary. So I'm going to talk about here. Here is what? Positive part. Understood? So here's positive part. Here's negative part. You got it now. That's why in your lecture note, we have what? We have negative part. So again, I'm going to write the example number 4 from what to what? Look at it again. 0 to 1, yes. Dx x minus 1, 1 minus x. Does not make a sense, okay? The same idea. So in my mind, I am from 0 to 1, and I'm talking to here with negative. So that's why I say from A, B, whatever you like, to 1 from left side. Understood? Hello? You got it? So right and left is depends on the boundaries. Okay. And I know that one will change to A0 dx 1 minus x. Understood? Good. And go to solve, forget about the limit, try to solve the integral. So how we solve that one? Thank you. We need a minus here. The derivative of denominator is minus dx. So we say is ln of 1 minus x. From where to where? To a. Thank you. Then later, again, the limit does not make any problem for us. Just do it. I know first minus ln of 1 minus a minus of the rule lower minus ln of 1 minus 0. Am I right, Jamaat? Hello, guys. So minus multiply minus plus, and I know that one will be what? Ln of 1, and ln of 1 is equal to 0. We repeat that one many times. Thank you. So it remains, our result is like that. Do you have any question about it? No. Now it's time to substitute the limit. A to 1. So we have minus ln 1 minus a. So how we solve that one? And that's why I say it's important to write the left and right. Now you know what? 1, yes, 1 from left means that what? 0.999. Am I right? So if I put 0.99, I will get what? 1 minus, in my mind is minus ln of 0.999. Am I right? 1 minus, sorry. 0.001, because I have 1 minus 0.999. Understood? This is just for getting the value, just for imaginary. It's not real. You cannot write like that, but in your imagination it's good to get the result. So, and ln of 0.001 is equal to what? No, because ln of 0 is undefined. Do you remember the image of the ln? Thank you. We see that if we are here, if ln of x, okay, that one's ln of x. If the limit of x approaches to infinity, the limit is going to where? To infinity. Am I right? Understood? And I say if we are going to 0, here's a 0, but right of 0, because ln of 0 undefined, ln of negative undefined, but ln of 0 of positive means ln of 0.001 is defined. But where we are close to that one. I am closing to the 0 from the right side. Look at the image. I'm going to be here. So the image is going to where? Negative 0, infinity. So when ln x approaches to 0 from right side of ln of x, I will get negative infinity. I'm going to 0, careful. Here's I'm going to infinity because we don't have a 0. So in that case, look at our result. I'm close to where? 0.00. So our limit, when a approaches to 1 from negative part, minus ln of 1 minus a, in my mind, after a little bit calculation, quickly in my mind, I say this one is like ln of 0.001. And I know that one is minus infinite. Am I right? Then minus multiply minus. That's why the result is what? Infinite. And it's converge or diverge? Diverge. You got it, dears? Understood? And this example, I brought it many times in the exam. The example number 5, I like it. So careful, try to understand all of them. Why I like it? Because many students, they forget about the vertical asymptote. Especially in exam, when you saw the boundary, take care. Like a blinking, like alarm. Take care, there's something wrong. Because I'm not bringing easy things. You know what I mean. You know, good. So we need the idea. So the idea is here, right? So write for yourself. When you saw the boundary, first of all, think about vertical asymptote. Maybe it's the vertical asymptote. Maybe it's the improper integral before you are substituting and solving. So here we are. We have x minus 1 2/3 from 0 to 3, I think, yes. Where's the vertical asymptote? Is equal to what? 1, right? If I put 1 here, I'll get a problem. So here's the problem. So how we solve that? Because you need to select. So I'm asking myself, that number is here or not? Here. So you have an improper. Okay, in the middle or up or down? Maybe in the middle, I don't know. When I say middle, I don't mean exactly the middle. It's between. Let me say it's between them or not. Yes, between. So how we solve that one? It's easy. We will say, before doing limit, we are going to separate them from 0 to 1 plus 1 to 3. Understood? The same integral. The same integral. So now you can deal with it. Whatever you like to solve, so okay, solve them. Anyone that you like. So how we solve one by one? So this, I'm going to recall that one as I, and I'm going to let not be I1 and I2. Okay? And this is my integral as I. The previous one is I. So how we solve I should solve separately I1 and I2. I sub 1, I sub 2, and I will get the result. Do you think it's hard? Do you think you can also solve that one from 0 to 1, x minus 1, 2/3? So we solve that one. I know that one is equal to what? Let me change to the another color. Okay. So S is equal to what? Yalla. 2/3 or 3/2? 2/3, good. So S is equal to I1 equal to limit of A approach to where? Y from left side, because I'm from 0 to 1. I am here, right? So 1 to the 1 from left side. Okay. That integral from 0 to A, 1x minus 1 minus 2/3 dx. You know, now I have box d box, that's why. Understood? Hello? Clear? Okay, so equal to limit of A approach to 1, If I put plus 1, I will get what? How you solve box d box? 1/3. Okay, so our result will be 1/3 x minus 1, 1/3. Am I right? From 0 to 1. And 1/3 in my mind is cubic root. And that one will come to up. So I will get what? 3 limit A approach to 1 cubic root of x minus 1 from 0 to A. Understood? Thank you, cubic. Good. What else? A approach to 1 from left side. Okay. And cubic root of A minus 1 minus 1. Am I right? I put a 0. I got minus 1. So tell me, cubic root of minus 1 is equal to what? -1, yes. It's not undefined because we have odd. So I'll get -1. So the result will be what? And if I put 1 here, I'll get what? 0, thank you, huh? In my mind, it's like that. I say it's equal to -1, okay? And here's 3, and I put the limit here. The limit of 1 minus -1. So 1 minus means that 0.999, and 0.99 minus 1 is equal to what? 0. Am I right? And square or cubic root of 0.0001 is a little bit close to what? 0. That's why I say 0. Yes, minus 0.0. So I'll get minus, and will be what? -0. And -0 is 0, right? You got the idea or not? Dears, I'm reviewing Calculus 1, limit, chapter 2. Do you have a question about that one? So we put it like that in your mind. If it's no problem, substitute it, put it in its place. And imagine, because why we say 0.999? Because we know the limit is not exact value. For example, if I say f of 0, I get 0 means that exact. But when I say limit of this function, x approaches to somewhere, any number, and I get 0 means that I'm close to 0. I'm not exactly in the 0. Maybe close to the right side or left side, but together I'll get a 0. So that's why our results will be 0 plus 1. Am I right? Here we are. So I will be what? I equal to 3 multiply 0 minus 1, and I'll get 3. Do you have any problem? Did you understand? Hello? Did you understand? Good. Now I'm going to solve double I. Double I is equal to what? It was about 1, 2, 3, right? Dx from what? X minus 1, 2 over 3. Am I right? Let me check it again. I'm sure, but it's okay to get it. Here we are. I2 from 1 to 3, x minus 1. Okay. So again, I'm going to use another color. Not double I, sorry. I2. So I2 will be the limit. Let be B. B approach to something. Maybe in your books A. I don't know. I forget about the numbers. So it's equal to what? To 1. Okay. And B 2, 3, x minus 1 minus 2 over 3 dx. So 1 is between what? Between 1 and 3. And I'm talking about where? Right? So we are talking about a little bit more than 1. Talking about 1. So careful. And I2 will be limit of b approach to 1 from right side. And that one again will be what? 3 cubic root of x minus 1. Am I right? From where to where? B to 3. You know how. This box, D box, and go on. Then we will get 3 limit of b approach to 1 cubic root of what? 3 minus 1. Am I right? Minus cubic root of b minus 1. Do you have a problem? Upper minus lower. Good. So I will get what? 3. That one is constant. It will be what? Cubic root of 2 minus limit of cubic root of b minus 1 will be approach to 1 from right side. So tell me about the result of that one. Is equal to what? 0 again, right? I put greater than 1 means that I have 1.001. So 1.001 minus 1 will be 0.001 again, and cubic root of 0.001 is close to 0. That's why we say is equal to 0. Thank you. So now we will get 3 cubic root of 2. And this is I2. Now I equal to I1 plus I2, I sub 2. So it's equal to 3 plus of what? Yeah, 3. Maybe we did some mistake or I don't know. Let me check the result. Here's good. So here we are. It wasn't hard, but actually need work. You should sit down with a pen and paper and solve it again and again and try to solve the exercises. I think it's not hard. So here we are. We finished chapter, what do you say? Chapter 8. If you have a problem, let me see. If you don't have, let me stop that sharing the. Okay. Problem? Understand? Okay. So I'm going to stop the video.